Hi, this is Thomas Earl, and welcome to another episode of the Real Digital Transformation podcast series. I have with me today Wajid Khattak, who is with Jaguar Land Rover, where he is a technical specialist in the Prognostics Pattern Recognition Area of the vehicle health domain. Wajid, welcome.
Oh yeah, hi there, Thomas. Yeah.
Thank you for being part of the show today. And as you can see from our visual aid here, we're going to be delving into the mysteries behind model training. We're going to try to help provide clarity as to what model training is, how models exist, what algorithms within the context of data science are, how they are part of the model training process, and just try to better unravel that important core part of contemporary data science, the learning aspect behind what's driving machine learning and AI systems today. And Wajid, you are deep into this technology and these processes on a daily basis with your work for Jaguar Land Rover. So, the first thing I'd like to ask is, and we have a few figures that we're going to be looking at here from the fundamental machine learning course content. The first thing I'd like to ask is if you could, in the most simplified English possible, explain what model training is.
Sure. So at its very basics, it all starts before even the model is born. We have our algorithm. So the data scientist, machine learning engineer, they would choose some specific algorithm that's fit for solving whatever problem they're trying to solve. And once they have chosen their algorithm, let's say it's a decision tree or it might be some sort of a neural network, then at that time, let's put it this way, they have just got a bare bone. Okay, there's nothing there. Just having selected a algorithm, at that point in time, they have a model, but that model is just bare bone. It has pretty much no intelligence in it. So the next stage is the training bit. Now, we've all seen in terms of like what model training involves. It's all about training the actual parameters of the model. Now, I think at this stage would be a good idea to actually relate it to a more of a like a it's very in layman's terms, very like an analogy. So imagine there's a like there are like two fishermen and they're trying to catch some fish, and all they have is some sort of a fishing net. So now imagine that that particular fishing net is like a cone kind of a. So it's based on a cone. So it's like a funnel kind of a thing.
Mhm.
Now imagine that with each of the and so now I would start bringing in some of the terminology from, let's say we have a neural network. So each of the cells within the net, it has a weight attached to it. Again, you would have a weight attached to a fishing net. Why? So that it
Sure.
obviously if the net stays underwater submerged. Now imagine you have got those little weights attached to each of the cells of the fishing net. And so there's one person, let's say, on the left hand side of the net, and then another person on the right hand side. Now, it could be that you are only interested in catching a very specific fish. Maybe it's tuna, salmon, God knows whatever you're interested in. So, um, you don't just want to catch any fish, okay? So at this point in time, you have kind of chosen your type of fishing net, because again, there can be a you could be doing it like a casting the net, so some sort of a cast net
So
or a.
catching
Mhm.
that specific fish, that's the problem you're trying to solve.
Exactly, yeah. So you have been given a problem that, okay, go and catch some salmon. Okay, now that's your problem statement. So now you're gonna look into the arsenal of your tool. That okay, what is it that's gonna enable me to catch salmon without doing much effort? Put it this way. Okay, we are being
And the
lazy.
solution, if we relate your example to
Mhm.
the diagram we're looking at, the solution to that problem would lie in the results
Yeah.
that are being output by the model, as in the bottom right of the figure.
Yeah, yeah. So
Okay,
the result would be a nice, good salmon fish. Put it this way.
right.
Okay, yeah. So now we have chosen our algorithm. Algorithm in this analogy being the type of the fishing net, because there are like 20 different types of fishing nets.
Okay, so we're as a
Mhm,
fisher
mhm,
man, as a fisher
mhm.
person, we can choose from a number of nets,
Yeah,
and the problem we're trying to solve will determine that the criteria we use to choose the most appropriate net
mhm.
to provide us with the best results.
Perfect.
And
Exactly. Yeah,
so, relating that to data science model training, we
yeah,
have a problem we want to solve. We have a collection of pre existing algorithms we can choose from
yeah.
and then we try to pick the one that will give us the best results for
Yeah,
our problem. Okay,
that's more right. So
got
let's
it.
say we have chosen a decision tree because that's the best model that works best for solving that specific data science problem. So yeah, okay. So back to our fishing expedition.
Mhm.
Now, so we have chosen our algorithm slash fishing net. However, at this point in time, that net, let's say, let's try to make it a little bit more interesting. Our problem that it's not just any salmon; it's a very specific breed of salmon of a particular size. Let's say,
Mhm. Mhm.
and that size is not like your common size across the world. It's like within this area, this salmon is of this size, this and that. So we are only interested in specific type of salmon. Now, having just that net is not going to help us to catch that specific type of salmon. So what we need to do is we need to customize our fishing net. So, and this is where the model training bit comes into play. Now, in terms of customizing our fishing net, how are we going to do that? Remember, we had those little weights,
Mhm.
those literal weights attached to each of the cells of our fishing net. And please keep in mind that our fishing net is like a more of like a cone shaped net, so like a horizontal funnel. So the widest end is on the left hand side, and then as we go to the right hand side, it gets uh, smaller and smaller. Okay.
The cone shape of the fishing net
Mhm.
is corresponds to the algorithm we chose. So had we wanted to solve a different problem, we may have chosen a fishing net of a different shape.
Perfect. That's right. So it's
Okay,
the shape of the net is our what constitutes the difference between different algorithms.
that's our algorithm. And
Yeah.
then now we need to customize it further because it's a generic fishing net. It's a
Mhm.
generic algorithm
Yeah.
that is used throughout the data science community. Um, and now, but our problem is not generic. Our problem is unique to our business. We have a specific problem we want to solve. So the generic algorithm we've chosen is our best starting point. The salmon we want to catch, that cone shaped net, is our best starting point. But we know that because of the distinct requirements of our problem and the distinct objectives of our solution, we need to further customize that net.
That's right. Yeah.
Okay.
So we then remember we had two fishermen on either side of the net. So now we get into the business of customizing our net. In other words, training our model. So what we're going to do is let's say we have some friendly salmons floating around, let's say. So what we do is we kind of push one salmon from the left-hand side, and we want to see that would it actually be actually caught when it emerges on the right-hand side. So the objective is to catch it, put simply. But we want to make sure as it goes through the net, it gets into the right kind of like the catching area on the right-hand side.
Mhm.
So as we push the salmon, our friendly salmon, and let's put it this way, our friendly salmon is our example data, is our historical data, is our data that we already know, where the target class is already known. In other words, we already know that this is exactly the salmon that we need to catch.
Mhm.
Of 20 other different types of salmon, this is the one that we need. So in other words, this is our example salmon that we already have.
So relating this to the next figure that's being shown,
Mhm.
what you just described, the analyst is us, is you. You're the one setting all this up, and the historical input data that you're feeding into the model um, corresponds to the type of problem we're trying to solve. In this case, it corresponds to the specific type of salmon
Mhm.
we're trying to catch.
That's right. Yeah.
Okay.
So as the fish passes through the different cells of our net from left hand side to the right hand side, then what's going to happen is then the person on the right hand side of the net, he's our like the observer. Okay, so he's gonna check that is the in terms of the those little cells within our fishing net, are they properly kind of like aligned to the in a way so that they can capture that our specific salmon. And to
Mhm.
start with, all of the cells would be of the same shape, put it this way. But what we're going to do is once we pass our first salmon, so then the observer is going to tell us, like tell the person on the left hand side that, hey, the first one, we didn't manage to catch it because it just went through all the, cells and kind of disappeared. So that's our
The
kind of, sorry, yeah, wait.
the two people fishing right now, the one
Mhm.
on the left and the one on the right, which one is the analyst?
So to be honest, it's a tag team kind of a situation. So both
You're-
of them are working together. So you could say that both of them are our analyst or our data
Okay. In
scientists in
this
this case.
example, why do you have two analysts? Why
So
the team?
yeah, okay. So in this case, just to kind of like put it into an interesting analogy, because if you go back to the world of neural networks, then as the examples are flowing through our neural network, then that's the forward pass. Okay. That as the forward pass occurs, then there is some loss that we are determining. We are finding out that, okay, is our model doing a good job or a bad job? So that's what
Mhm.
happens on the extreme right hand side. This is what the other person is trying to do. Like it's the other person that's telling the person on the left hand side that
Mhm.
how good or a bad job the fishing net is doing at the moment. But
Okay.
obviously, in terms of machine learning, then it's all automated. So on the right hand side, once the example has gone through the neural network, then there would be a loss function. We would determine that, okay, how good or bad we did. We'll find out that, we are this much away from our original predict. Like it should have been a salmon, but in reality, is something else. So then,
Okay. So, just taking a step back here, with this is the final diagram we're looking at now. The initial data we feed into the model is also vanilla data about the type of salmon we're trying to catch. So we've taken a generic algorithm as a starting point. We have fed in to our system training data, which is relevant to our problem. So in this case, training data specific to the type of salmon we're trying to catch. We get results from that. And those those results, the cone shaped net we're using with the specific weights that we've added to target the salmon, um, it's it's the iteration of this process whereby we input training data, we assess the results, we introduce new data or adjust the data to better train the model. We go through a cycle of doing this, which would, in our example, correspond to us adjusting those weights each time to just
Yeah,
optimize the efficiency, the effectiveness of our net before we actually deploy it in the ocean.
that's right. So yeah, that's
Okay.
exactly. So the person on the right hand side, it kind of gives us a feedback that, hey, we didn't manage to catch the salmon so in the very first try. So we can call it the epoch in the very first kind of cycle. And then what we do is the person on the left hand side goes and adjusts those weights for individual cells within the fishing
The
net.
person on the right hand side giving us the feedback, if we
Mhm.
relate it to a data science system, is that the system giving the analyst the feedback?
Over there, it all happens pretty much automatically. So that's part of the actual. So whichever machine learning, let's say, library you're using, then the this whole process of feeding the data in. Once you have specified here is our training data, and here's the loss function, and a couple of hyper like some of the settings slash hyperparameters. Once we have tuned that, then the rest of it all happens in an automated fashion. So there's like you don't really need a person as such. So the
Hmm.
person in our fishing expedition is just so that we can relate it to something. But this, in terms of adjusting the weights, that all happens automatically based on the feedback that we get from our loss function.
So, what does the analyst do manually as part of this process?
So in terms of the entire training, so before you can start the training, obviously you, as we just discussed, that yeah, you need to make sure you have selected the right algorithm. So that's in terms of the involvement of the analyst or data
Hmm.
scientist. So the story starts from there. So you have to select the right algorithm, and then you have to choose certain hyperparameters. So each model would have some sort of hyperparameters. Now, the hyperparameters would be like what's the batch size of the data, how many epochs, like how many cycles of training, or the learning rate, and what kind of regularization, this and that. So all those things are something that the data analyst or the data scientist, that person has to specify them. They have
Right.
to set those. So these are like our tuning knobs.
Those are critical
Yeah,
decisions that the
exactly.
analyst needs to make correctly for
Mhm.
all of this to perform as expected.